Hello, my two tables. So today we're gonna tackle on bone, cartilage, and muscle tissue. So there's a total of 8 slides. Credits to Junquierra Basic Histology Text and Atlas and Histology Text and Atlas by Ross and Pawlina, and also slides taken from the laboratory. Okay, so let's get right to it. The first one is your adult hyaline cartilage. So always take note of the function first and on the representative organs. So the function for this is it provides smooth and low friction surfaces in joints and also structural support in your respiratory tract. Therefore, it is found in your larynx, the rings of your trachea or your trachea, and the plates in your bronchi, and also in your synovial joints, okay, for the articular surfaces. So just take note of at least 2 to 3 examples for of representative organs, okay? So larynx, trachea, bronchi, and synovial joints. So here you see, if we zoom it in, they function again for support, okay? So a cell family is said to be 4 to 8 chondrocytes in one lacunae. So the lacuna or the lacunae is the pouch containing your corresponding chondrocytes. Okay, so here are your chondrocytes, the nucleus of your chondrocytes. So this has two, no? So this is the lacuna, plural, and this is your chondrocytes. And also you have to take note, aside from the cells present and also the surrounding covering of the cell, you have to take note of the extracellular matrix here, so the surrounding areas here. So there is type 2 collagen, okay? Type 2 collagen is present, and also aggrecan. So aggrecan is important because this is a proteoglycan that is said to contribute to the basophilic color of the matrix, okay? So aggrecan, proteoglycan contributes to the basophilic appearance of the matrix, but for this it's particularly red. We'll see the textbook specimen in the next page, so hopefully it will be similar to it, okay? And the perichondrium is also the outer covering surface that will enclose the cartilage tissue, okay? So here, perichondrium is a dense fibrous connective tissue with flattened cells. So this is also how your chondrocytes will obtain nourishment, okay? So this is how it looks like for your adult hyaline cartilage. I'll erase it so it will look cleaner. So take note of the extracellular matrix color, what is present in your extracellular matrix, and also how the cells are grouped. So here, this is a zoomed in version of the previous one, okay? So the shape of cell or your chondrocyte for adult hyaline cartilage is said to be large, spherical, and a round oval nuclei. And in the periphery, you have flattened chondrocytes here. So in textbooks, like in your Junquierras, this is said to be a chondroblast. It's still a chondroblast. It's elliptical, the nuclei. It's found in the periphery and it's still immature. Later on, when it will go in the central part of the matrix, it will slowly secrete collagen, okay, and other extracellular components, and then the nucleus will be round now, and also it will occupy a lacunae, okay? The moment it secretes collagen and extracellular matrix components, nucleus will be round and it will occupy a lacuna. Alright, so here, this is just a textbook look. So here you can really appreciate that it's more basophilic, no? Rather than some slides, representative slides, the matrix is basophilic. Okay, so I already said what was important. So here you see a chondroblast. I'll change the color. Chondroblast, because it's elliptical. You see here that this is your lacuna, and your chondrocytes, okay? The lacuna is the covering for your chondrocytes. Okay, so here, take note of the specimens, okay, or the organs, at least 2 to 3. larynx, trachea, bronchi, synovial joints. So the next one is your elastic cartilage. This one is still is surrounded by a perichondrium. You see here, no? This is in the lab. And what is particularly more distinguishing for your elastic cartilage is that they have dense or dark bundles of elastic fibers. You see some of these highlighted or extra dark areas, no? So that that's one way according to Junquierra where you can identify your elastic fibers better, no? And the cell families, the lacuna are larger, said to be larger. If only I took a big zoomed in picture of this or a HBO picture. And then cell families are few though. And the preponderating fiber is your anastomosing branching elastic fibers. But take note that in your elastic cartilage, you still also contain type 2 collagen, okay? There's still type 2 collagen, but now you have your elastic fibers. Alright, so where is the location for your elastic cartilage? It usually starts with E, no? At eustachian tube, epiglottis, and your ears, the pinna of your ears. Okay, so take note that the lacuna are larger. The dense, evident elastic fibers present, representative specimens or organs, and they function also for your support of your soft tissues and flexible shape. Okay, here. Oops, sneeze. So it's still basophilic, and here you see actually dense your elastic fibers. It's darker and can be seen as your darker components here, okay, in your matrix. Your chondrocytes are still present. So really, what helps you to differentiate this from hyaline cartilage is one of it is really the presence of your dark evident elastic fibers. Okay, so take note of the function again. So the last one is your fibrocartilage. The fibrocartilage is said to have a herringbone appearance, no? If you see it here, and in your fibrocartilage, this will follow. This is arranged axially, no? So you also see type 2 collagen and type 1 collagen along with your dense connective tissue. Okay, where is it found? Your intervertebral disc. It's found in your intervertebral disc because it prevents damage to adjacent vertebrae, so it acts as a shock absorber in your vertebral column. Shock absorber, and it will functions as a lubricated cushion, no? So one vertebrae won't really cause that much friction to the other. So it's found in your intervertebral disc. Also, your symphysis pubis. Okay, those are your representative organs. So here, you see, what's also important to note is that in your fibrocartilage, there is no more perichondrium, okay? No more perichondrium, unlike in your elastic and your hyaline cartilage. The preponderant fiber here is your collagen. You still see your chondrocytes arranged in rows or axially, and sometimes you can also see even fibroblasts present. It will be shown in the next slide, okay? So it functions to provide cushioning and tensile strength and resistance to tearing and compression, okay? Take note of the function below. Very important. Provides cushioning, tensile strength, and resistance to tearing and compression. There is no perichondrium. Type 1, type 2, major cells present, chondrocytes and fibroblasts. It's arranged axially, also like a herringbone appearance. Okay, here. So you will actually see here that this is your chondrocytes, and these flattened elliptical like nuclei are your fibroblasts. Okay, it's arranged axially and found in your intervertebral disc. So here is a summary of what I first mentioned, no, and how you, with one method to differentiate this, no, your dark elastic fiber bundles. That's one way. This one. So this is like a typical clean for me, huh? Typical clean chondrocyte and lacunae appearance, no? That's how it is. And this one is a herringbone appearance, arranged axially. So this is just some tips to easily, with a one step, you can identify them, hopefully, easily. Herringbone appearance, arranged axially. So this one, trachea. This one, epiglottis. This one, intervertebral disc. Okay, sorry for my handwriting. So, okay, anyways, I'll proceed next to the bone. So here is your osteon. So this is representative, or this is one of your units for your bone, no? This is your compact bone there. Okay, so here in your compact bone, an osteon is said to be one of the basic units of bone. So let's just dissect the parts, okay? So here in the center is your central canal. What's important with your central canal is that it contains your blood vessels here. Here. It contains your blood vessels and your nerves and your lymph, no? So this will also help serve as nourishment for your compact bone or your osteon. Then afterwards, you will see here around it, it forms concentric circles around, okay? Oh my god, I'm messing that picture up. So this is your concentric lamellae. So next is also your still just like your chondrocytes, your osteocytes are housed by a lacunae, okay? So the darkened areas here are your osteocytes, okay? Here. So concentric circles, this is your concentric lamellae, darkened nuclei, osteocytes housed by your lacuna, and the central area is your central canal. Okay, you will see fine canaliculi here present, this label as C. These dendritic-like fiber thread-like processes, no, those are your canaliculi. Okay, so there, and then I'll try to clean this up so you can appreciate it more. So please take note of canaliculi, dendritic-like processes. Osteocytes housed by your lacunae, and that's the cells found in your compact bone. Your concentric lamellae and your central canal that provides nourishment, that has blood vessels, lymph, nerves, and your endosteum. Okay, so this is like a representative also for your osteon. Here is in the lab, no? So you also see cementing lines here. The cementing lines function because it will indicate a boundary from one osteon to the other. So you see this evident whitened area here. That is your cementing line. Okay? Demarcates one osteon from the other. So I already explained what canaliculi is, Haversian canal, and your Haversian lamellae or your concentric lamellae around, okay? So also there's outer covering. Since we're talking about bone, it's not perichondrium anymore, it's periosteum, okay? So the rest of this I think I discussed already. So the last part is your endochondrial ossification. To make it short, this is like the transformation in your developing long bone from cartilage to your bone. Okay, so you have distinctive areas present. Let's just focus on the textbook specimens here, unlike here where there's one from the lab, because you can really appreciate it in a whole zoomed out view. Okay, so you have the reserved cartilage or your resting cartilage. So this is just the area where you have typical cartilage, no? So you have chondrocytes housed in a lacunae. Next is your zone of proliferation. So your zone of proliferation is when your cartilage cells divide and enlarge. Okay, so balik ta ha. So reserve or resting cartilage is just when your chondrocytes are just sitting, or they're just present there. When you talk about proliferation, your chondrocytes divide and they enlarge. They secrete collagen and type 2 collagen, to be specific, and also your proteoglycans. So they are arranged in rows as well, okay? So they're actively dividing, in short. Next is your zone of hypertrophy. So your zone of hypertrophy now is when these cells, or your chondrocytes, will mature, they will become swollen, and they will enlarge further. Okay? If I zoom it in, man god, it's very pixelated. So this is also known as your maturation zone. They will enlarge. By the word hypertrophy, they will enlarge, okay? And they are said to be cuboidal in shape. So cuboidal, and they will enlarge even further. Next is your zone of calcification. So your zone of calcification is when now your chondrocytes will undergo apoptosis, meaning they will die as programmed cell death. So when they die, they will release out in the matrix. They will release matrix vesicles and your osteocalcin. So this is just extra information which I think was lectured. Osteocalcin will herald or will now force the bone to calcify, or it will initiate calcification with the release of these matrix materials and osteocalcin. And with calcification, that will calcification that will also lead now to bone growth or bone formation. Okay, in the next phase. All right, so to understand this better, this is also very well summarized in your Junquierras. Okay, and truly you can also see the difference from one stage to the other. Anyways, with calcification also, there will be hydroxyapatite formation, okay? Hydroxyapatite formation. And now your lacunae, so here, if only we can zoom further. Your lacunae that previously housed your dead chondrocytes will open up. So by means that they will open up, that's because they will release the extracellular material, okay? The matrix material and your osteocalcin. And the last phase is your zone of ossification, which isn't here. I'm gonna write that lang here, okay? The zone of ossification. Your zone of ossification is when bone tissue first appears. Capillaries and progenitor cells will invade the vacant chondrocytic lacuna. So remember, the lacunae opened in the previous step, the calcification release. So now the osteoprogenitor cells will invade and will enter the chondrocytic lacunae, and now you have your osteoblasts. So do your homework na lang and differentiate what is the difference between osteoblast and osteoclast. Okay? And how do you identify if it is osteoclast? So when osteoblasts settle in, they will secrete osteoid. And osteoid will now become woven bone. Okay? So here you see newly formed bone, no? This areas, okay? The dotted areas here in this cavity is bone marrow, according to this picture. So here, so zone of resting zone, this is when your cartilage are just sitting there and they're just present, okay? Proliferation zone, this is when your cartilage cells divide, they will enlarge, they will secrete collagen and proteoglycans, and they are arranged in rows. Your hypertrophic zone is when they will become swollen, Okay, so notice the difference here as to here. They're much bigger, the chondrocytes and the lacunae. So they will become swollen. They are cuboidal in shape. The way I understand with cuboidal is that the nucleus is always center and it's equal parts in all sides, okay? And then afterwards, yeah, that's it. So swollen, cuboidal, and enlarging still, okay? Next is your calcification zone. So your calcification zone, there is the presence of apoptosis in your chondrocytes. So this is when your lacunae will open up. Lacunae will secrete out osteocalcin and extracellular matrix components. Okay, and there will be formation of your hydroxyapatite. Okay, that's why it's calcification also. Okay, so there's it's not as clean in the picture as your hypertrophic zone, because it's leading already to the formation of bone. Okay, and usually it's darker staining, and then spicules of calcified matrix. Here you see it, darker stain, spicules, apoptosis, and then release because lacunae opens up. And our last one is your zone of ossification, where you have your osteoblast that will secrete osteoid, and it will lead to woven bone formation. Okay. Sorry, I just repeated what I said previously, so it will get in your head. And here, let's just take a moment to appreciate that zone, resting zone, proliferation got bigger, hypertrophic got even bigger, and cuboidal. Calcification zone, important parts here. Ossification zone, so your lacunae opened up. What replaced it was your osteoprogenitor cells, and osteoblasts come into play, and they secrete osteoid for the formation of bone. Alright, so this is a picture in your Junquierras. I think this picture is better though. Okay, you can really appreciate all the parts. Erase it so you can see it clearer. Okay, this is Junquierras again, and I won't repeat it because always what I said previously, it will still apply here. Alright, so the last part is your muscular tissues. So you have your skeletal muscle, cardiac muscle, and smooth muscle. So I just highlighted what we can appreciate in a laboratory context that will help you easily identify them. Okay, so for skeletal muscle, remember they are multinucleated cells, and usually the location of the nuclei is in the periphery, meaning it is not in the center. Alright, major locations. Your skeletal muscles found in your muscle groups, your gastrocnemius, for example, your biceps, your tongue, your diaphragm, upper esophagus, because it's mixed, no? Okay, and they function for voluntary movement. As to your cardiac muscles, for me, one of the ways to always differentiate them, especially in a longitudinal section, is that it branches. Unlike with a one straight line here with your skeletal muscle tissue, your cardiac muscle will branch, no? Like a tree. They also have the presence of intercalated discs. If you can HPO it and really appreciate it, there's a difference from it being straighted. So in skeletal muscle balicta, these are your striations. No, you see these fine lines or fine demarcations in these segments, whereas your cardiac muscle, it still has striations, no, but there are intercalated discs as well that you can really appreciate, especially if you really observe them one by one in HPO. Alright, they're found in the heart, and obviously they function for autonomic and voluntary pumping. So these are very good representations. Your smooth muscle are single, small, very, for me, uniform and fusiform. Fusiform means that it's widened in the central area and then it tapers out in the end. Okay, so it's similar now to a lemon shape, wide in the center and tapers out in both ends. That's what fusiform means. That's how they're characterized. And by the way, for cardiac muscle also, the nuclei are found in the center. Okay, whereas remember in your skeletal muscle, it is found in the periphery. So if and then smooth muscle is also still the same. It's found in the center. Okay, and your smooth muscle, they are found in many areas, blood vessels, in your arteries, in your veins, your digestive tract, uterus, bladder, no, and in your digestive tract, they are arranged in distinct layers that will promote peristalsis, which I will discuss in a few. And they are still involuntary movements. So, quick sum up. Skeletal muscle found in the periphery, multinucleated. Let's remember that. Cardiac muscle, they branch, intercalated discs, and central nuclei. Smooth muscle, fusiform. They are non-striated, and central nuclei. Okay, striated. So with your con. Alright, so here, this is what's found in the lab. No, so present in your heart and great blood vessels, your inferior vena cava and superior vena cava, branching and anastomosing. You see it here, no? They branched siya. It's very hard to appreciate intercalated discs here. Should go to a higher magnification. And your nucleus is at the center, and usually it's in 1 to 2 always. Okay, here, this is from your Junquierra. Intercalated disc present. Okay, nuclei is usually in the center jud. So it's not in the periphery, it's not outlying, unlike your skeletal muscle. And also, you should always study both longitudinal and cross-sectional, okay? For your smooth muscles. This is longitudinal, this is cross-sectional. Same applies. Here lang, for your cross-section is that the nuclei is in the center. It's hard to say if it's branching, no? But there's some, even with the actual lab slide, there's really a color difference. For me lang, this is just like, not really in the textbook, but just an observation. It's more of a violet pink color in the slide. And you can still see some branching, no? If you take into account the fine detail. Alright, so that's your cardiac muscle. So here, this is a repetitiveness side. Striations, intercalated disc nodule, and then branching, periphery out, multinucleated, and the nucleus is in the periphery, and then afterwards your smooth muscle, fusiform. Well, you can really appreciate it, no? And even the nuclei is fusiform in a way, but this is only for longitudinal. So yeah, just study what was mentioned previously. And here is your skeletal muscle. So again, it's found, your nuclei is found in the periphery. This is actually a fibroblast, okay? So anything that's elliptical and more darker, that may be a fibroblast. This is your nucleus for your skeletal muscle found in the periphery. There are striations present here. Alright, and then afterwards, this is your longitudinal, no? Take note of the periphery nucleus jud, guys. So give me 2 specimens, tongue, gastrocnemius. Here, for your cross-sectional, well, it's not violet, the nucleus is not in the center. The nucleus being in the periphery will really give it out that this is skeletal muscle. Okay, and the last one is your smooth muscle tissue. So again, it's fusiform. It's very clean and elegant and uniform in appearance. Fusiform. The nucleus is in the center, even in the cross-sectional. So see, it's not found in the periphery. And if you really look closer here to find detail, because this might confuse you, no? Because it's pink purple in color. Nucleus is in the center, but take into consideration a group lang, okay? So dissect it out. It doesn't really branch. No, they're really in singular, not singular grooves, so they're really single-celled or single muscles. Unlike your cardiac, na mo branched siya. Alright, so here's in the textbook also. So here you see outer longitudinal and inner circular smooth muscles. This is found in your digestive tract, no? You can see this in the muscularis mucosae in your, probably in your ileum or your lower GI tract, no? Because they function for peristalsis, the continued movement of food particulates, no? to aid in digestion. And here is an example in your bladder, okay? Digestive tract. And this is cross-sectional now. Okay, but this is really a good representative of your cross-sectional, while this one is a good also for this one for your longitudinal. And that is all. Thank you very much. Please study well.